Okay, welcome everyone. This is a Supercell seminar about developing next generation online games. I will focus on browser development and our first product called gunsign.net. And my name is Lassi Leppinen. I'm the technology lead and one of the co-founders of Supercell. I will start about my background. So I started my professional career in 2002 at Sumea as a mobile game programmer. When Digital Chocolate acquired Sumea studio, the studio was growing pretty rapidly, and I started to lead the whole programming department. I got tired to the manager job, so I wanted to do something like real programming again and concentrate on one project only. So that was good time to move to Remedy. So I worked with Remedy in Alan Wake for 2.5 years. I was doing gameplay and technology there. And after Alan Wake was shipped, it was again perfect time to move on, and I jumped to Supercell and was in the founding crew. And about Supercell briefly, it's a fairly new company, and all of you might not be familiar with the company. So Supercell was founded 1 year ago, and at the moment they are working 35 people there, and it's mostly really senior people and some more junior, really talented people also. And we just raised our Series A funding, that was $12 million, and we have 2 studios, one in Helsinki, in Ruoholahti, and one in Kajaani. And even this presentation is about browser games, browser game development. We are also focusing for other platforms as well. So, for example, the tablets and mobile devices are really interesting for us. I'll start by talking briefly about browser and Flash as a game platform. You have been probably hearing a lot of seminars already about browser development, but as far as I know, not single about Flash so far. So first of all, why we picked Flash as the platform is that it's the most widely spread platform, and it's really possible to do a mass market game for Flash. And some of you might think that Flash is for banners or something if you haven't been following the progress, but actually nowadays it's pretty good game development platform, and doesn't differ too much from the traditional, let's say, console game development. So, for example, when we hire new programmers, we don't try to look for Flash guys. Usually experienced C++, C# or Java game programmer is a better choice. And also on the art side, it actually reminds quite a bit of the traditional game development. Biggest differences are that the initial download, it needs to be really small. You need to be able to start the game really quickly, in a couple of seconds, so you can download probably a few megs that before the first screen must be visible. After that, you can load as much as you want, but the game needs to start quick. Probably another big difference is the release process and how the games are built. So in console game, for example, you just ship it, you are done with it pretty much. But with the browser games, actually the game development just starts when you release it first time. So at that point, you start getting all the statistics from the user behavior, you start to get all the feedback, and that's the perfect point to start really iterating and polishing, tweaking all the details. But yeah, in addition to that, it's not far away from other platforms as well. And rest of the presentation will concentrate on our first product, Gunshine.net, and I will cover topics like the tools development, game balancing, and client-server technology. In the end, I will show also a small demo about the new Flash Player 11. And first, the trailer, in case you haven't seen it. Okay, so that is Gunshine. As you can see, you can do pretty advanced or complex games with Flash nowadays, and it's basically a full-blown MMO game with all the like standard features, and also utilizes Facebook quite a bit and has few more innovative stuff on it as well. Okay, I'll jump into the tools of Gunshine. We had quite a big challenges when we started the game development. We knew that we are trying to do something that no one has tried before, so tried to design carefully and concentrate a lot of the content creation tools in the beginning. And one big question was that how can we really create all the content? If we want gameplay for tens of hours, even months, like how can we do enough? And we wanted at least like hundreds of different missions there, hundreds of different enemy types there, and also huge amount of different items like weapons and stuff. So there's plenty to explore and to do. We ended up these conclusions. So first of all, we wanted to do everything like in an extremely data-driven way. Like pretty much every game developer says that their game is data-driven, but I think that we took it a lot more further than the usually the game developers do. So a couple of examples like for example, the content guys could do like new enemy types, new character classes, even new character abilities without any programming help. So we just defined all the visual effects, all the sound effects, ranges, the area of effect, and all different parameters in a data table, and you could do new abilities in a data-driven way. And the main tools that we used were our own internal Gunshine editor. I will show a couple of screenshots of it soon. And another big content creation tool that we used was Excel. So pretty much there is no better editor for number-based content than Excel. So we decided that we will use such file formats that we can edit those directly with Excel. And the editor that we have, it's built on Adobe Air, and we decided so because we wanted to share a lot of code with the editor and with the game. So basically the editor, for example, uses the rendering that the game uses and pretty much loads the files same way as the game. Another big question was that how can we iterate all that content? It's not really like trivial to iterate, let's say, 200 enemy types really quickly after the release. So we started with the weekly production pushes after the first release. So basically we had just a couple of days to iterate the content and do some testing and just put it live. And we ended up doing a massive amount of different content validation tools because we wanted to iterate everything in wide scale all the time. So it was not possible to test all that, every single level, every single mission. That would have taken like army of testers. And basically we had 1 or maximum 2 days for testing everything and putting it live. So massive amount of content validation was the solution that we used. So in practice, what this means is that there are validation in 3 steps. First of all, in the editor, when you edit any single data table, any single level, there's all the time like warning window visible that shows all the dependencies that are broken or we tried to be really innovative, like all the mistakes that the content guys usually did, we did some kind of automated checking, like that showed an error or warning. And another step in the content validation was the game itself, so it was massive amount of code that just checked that all the dependencies were correct, and like if the mission goal was to kill 3 guys, there actually were 3 guys in the level, for example, of that type, like that kind of stuff. And most intensive validation was done in the third last step when we actually did the builds. So it went through all the levels, every single detail that we could possibly think. It was really time consuming to do that heavy like validation with all the levels, every single piece of content. So that's why it was only in the build process, like when we actually doing the release candidates. And here is a screenshot of the editor that we used. This is the level editing view. We actually had quite many different views on it, but I'll show this first. So this part here, it's just the preview. It's rendered with the game engine. It looks exactly the same as it will look in the game. That was the benefit of sharing the code. We tried to keep the iterations quick, so there was directly save and play button. So what it does is that when you click it, it opens this level directly in your browser, so you can test it really quickly. And here is the, as I said, there are some other views, other editors as well included here. So this so-called item editor basically means that if you click that button and characters are selected here, you would open a view that where you can modify the characters and customize those. And yeah, this is a bit stupid example because there are no warnings at the moment, but in practice, like that window was showing all the like results from the validation process, and usually it was actually quite packed with the warnings. Okay, and here the character editing view. On top here, you can see the actual data format. So we kept most of the data in this kind of Excel type format, just really single rows, columns, values, and just shows how the data is done. And on the bottom, we have the custom editing view that was different for pretty much every single data type, like whatever was needed for that specific type. So for example, now in this character view, you can select the clothes for the characters, weapons, death effects, hit effects. You can preview also all the animations, so this part here is for the animation preview, and you can even try the special abilities in here. So basically it pops up a dummy enemy there, or some other object that where you can try how it looks, the skill, and how much damage it does, and so forth. And yeah, there were plenty of other views as well for many different data types, and also one view for editing and doing the missions. Okay, we also knew that when we are doing a browser game, we are doing MMO games, so it's super important that we can keep everything in balance. The difficulty level, the prices, and there were like huge amount of numbers that we wanted to keep in order and keep it like difficulty correct and the game balance for in all areas correct. And also now a couple of like methods that we used to balance the game. So first of all, we noticed that it doesn't make any sense to try to define the numbers, let's say damage for every single weapon separately. It would have been a mess basically. And as a result, we decided that we will group all the content in to basically classes or groups. So, for example, in the enemies, the difficulty is based on basically three facts, like the character class, experience level, and the special abilities. And so basically, if you the classes like heavy guy, light guy, medium guy, and something more advanced like healer or whatever. Another big thing was the experience level. Basically combination of character class and experience level, for example, defined the hit points for the enemies. I will show a small example in the next page. And also the special skills, special attacks, they have their own like balancing methodology, but like that was the only part that was more or less manual balancing. So what kind of skills are you picking for this enemy type, and we need to test those quite a bit that they felt good and none of the enemies were like super difficult. And in the weapon side, example there, so we used weapon class. It was actually pretty close to the character class, so it gave some of the scales for the damages and range and so forth. Item level, it's actually pretty close to the experience level. The only difference is that we wanted to have more variation, let's say, weapon that you can use on experience level 3. We wanted to have more variation there, and actually it's possible that there are like 5 different item levels that match with one experience level, for example. And last thing in the item balance was the rarity. So basically, if you had a common weapon or rare weapon, the rare weapon could do, for example, 50% more damage. So it gave some of the scales there. And with those, and just pick those 3 correctly, the weapon was good and like it felt good. And it was then about the weapon class balancing if it didn't. And this is one methodology that we used quite a bit, slicing. So it's actually really old method from MMO games like World of Warcraft and so forth, but I'll just quickly tell how we used it. So basically it means that we divide every single attribute to kind of 5 level slices, meaning that there's one slice from level 1 to 5, another slice from level 6 to 10, and so forth. And in this way, we can modify one slice of 5 levels without touching rest of the game. So actually, for example, here, so the heavy enemy class hit points in level 1 and 5 are there, and it was basically going in a linear way in between the levels. So it's kind of 2 keyframes that define the difficulty for heavy class in level 1 to 5. And as you can see, the matrix that defines the hit points for the 3 different enemy classes from 1 to 30, it's actually pretty small and nice to modify. And if the alternative would have been that we have like 300 guys and you put hit points for all 30 levels separately, that would have been pretty insane. Okay, and I'll also talk briefly about the client-server architecture that we used. It's quite different compared to traditional games, but it's actually fairly common in many MMO games, but most of you aren't probably familiar with this, so I'll talk about it briefly. So the basic idea in the client-server loop was that we had exactly same game logic running in both sides, in the client and in the server. So basically what it meant was that we can just send the player input to the server side, and it's guaranteed that the logic results exactly the same as in the client side. And this was really good solution in that sense that we were able to keep the data traffic extremely minimal, like just the player input, and server also sends all the input from other players to everyone who is in that zone. And another big thing was that the game is quite difficult to hack, so it's not enough if you edit the local memory or do any tricks like that, because we don't need to trust the client. We only need to take the input. We can do all kinds of validation there, but we only trust the logic that is executed in the server side. And that was pretty nice and good solution. Okay, so the server side, it's actually Java, client side, it's ActionScript 3. So there was of course the problem that how can we get the same logic to both. So we decided that we are building a small converter that automatically takes the ActionScript code and converts it to Java. And the results are actually pretty good. It takes probably like 5 seconds or so to convert the code, and you can start the server, start the client, and everything is okay. Of course, there are some like things that say the ActionScript side doesn't have as much compile time validation for the code. You can do all kinds of stupid mistakes there, and then in Java side it doesn't compile correctly. But those were really minor things and really usual, like just like few second fixes. Okay. That's from the server client side. Okay, just to wrap it up. So in the tools side, super data-driven approach. It's really recommended for all the browser developers, also all the MMO developers. Content validation tools. I encourage also people who are doing this type of games to invest really a lot of time into that, because as a result you can do quicker releases and rely more on the automated validation. And balancing, I think this is pretty good for almost any experience level based game. So the balance based on classes and the slices of 5 levels. And the same game logic is run in both client and server side. Okay, at this point I will show you a small demo about Flash Player 11. So this is actually running on my browser here with the beta version of the new Flash Player. Okay, so basically what you can see there, it's like the first one is the FPS. It runs 60 frames per second. It's quite nice amount of textured triangles there, and there's also the mutants per second figure shown. And this demo here, it was just thrown together really quickly. We just took one character from the Gunshine and put it here and tried how many we can draw easily. But it just gives you some kind of idea what you can do with the Flash nowadays. Just to give you some kind of idea about the performance is that with the modern desktop PC, it's possible to run multiple times more polygons compared to PlayStation 3. So you can really do pretty much whatever you want. Of course, in browser, you need to keep the download light, but the rendering itself is like super fast. And yes, we are looking for talented people, and we really believe that the best developers will do the best games. So if you are interested, we also have a booth here in Assembly, so you can visit there, or of course you can go to our webpage and check the contact details from there. Thank you. That's all. And we have still some time for questions. So if you want to ask anything, feel free. Okay, do we have the microphone somewhere?
Yeah, I was actually wanted to ask what kind of a performance impact it would have if those mutants would be, user-driven. If somebody would be, controlling them, would it have some kind of an effect on performance?
No, not really. Not really. That was just basically running random animations there. So if it would have been user controlled, that wouldn't have a big difference. And it wasn't optimized at all. I pretty much guarantee that you could get 10 times more polygons out if you would do it in an optimal way. Any other questions? Okay, thank you.